Okay, let's start with a little preview of what I'm going to show you how to build today. This is, I call this application Remote Controlled Objects, and it consists of two user interface components, a control panel over here on the right, and a floor, which has the title Robot Floor. And the purpose of the app is to add robots to the floor. I'm calling them robots, and then move them around. So when you add one to the floor, you can click on the move button, move it. When you first add a robot onto the floor, it's facing a certain direction, and yeah, so it's facing a certain direction, right? So in this case, it's facing east, so it's moving to the east, and then if I turn right, it's going to move to the south, right, relative to the robot floor window position. I can add another robot. Okay, I'm still selected on the first one that I added. If I click next robot, then I'll move the second one that I added, just like that, right? Now this is just a demonstration program on how to use an inheritance hierarchy in order to create what I'm calling remote controlled objects in this case. Okay, so it demonstrates the use of interfaces, an abstract class, event handling, complex window manipulation. Well, it's complex because let's say if I close this control panel here, I close it like that. And it's like, uh-oh, well, now how do I get my control panel? So if I click on the floor, it'll show the control panel again. So now I'm just back to moving it like I was. I can add another robot. Okay, I can turn him right immediately if I want to, and then I can head, well, next robot, head south, turn right. Okay, you're only controlling the one that you've got selected. It's hard to tell which one is selected because I haven't put that type of code in, right? So if you wanted to play around with this program, you certainly could. So anyway, this is the application. It's very simple in some ways and complex in others. So let's take a look at the architectural diagram. Okay, this is the architectural diagram for the Remote Controlled Objects project. In the center, I have the main application. It implements the iHandler interface. The iHandler interface is introduced in order to break the dependency between the control panel, which is going to be a window also. It extends form, and the main application. And when we get into the code, you'll see what I'm talking about. On the left-hand side, we have an inheritance hierarchy over here, beginning at the top, with the iControllable interface. And then the abstract class controllable object implements iControllable. The implements in a UML diagram is a dotted line with an arrow that points up to the base class or interface. So controllable object implements iControllable, but it's going to be abstract because it will leave off several of the methods that are declared in the iControllable interface. And then the one concrete class for this example will be a remote controlled rat. Okay, so the rat class will implement the methods that are left off of the controllable object. And then any other concrete classes that you wanted to add, like for example, you could have remote controlled person, remote controlled droid, remote controlled whatever. Okay. The remote controlled objects are going to be moved around a floor. The purpose of the control panel is to add new remote controlled objects to the floor and then control their movements and select which one you want to move. And that's the architectural diagram. Let's now take a look at the code. I'll start with the iControllable interface. And then in fact, I'll start on the left-hand side. I'll code up the iControllable interface, the abstract class, controllable object, and then I'll create the rat class. I didn't mention this before, but these dotted lines here are dependencies. So over here, you see where my cursor's at, I'm wiggling it. The main app will have a dependency on iControllable interface and the rat. Okay, because I'm going to have a collection or a list of iControllable objects. It will also have a dependency on the control panel and the floor, and the control panel will have a dependency on this interface I'm calling iHandler. All the event handling code, well, I'd say most of it, for the button clicks anyway, are going to be located in the main application. When I create an instance of control panel, I'm going to have to pass in some objects that which will be this main app object, this class, right? When I create the when the class is created, I'm going to pass in a reference to it. But in order to break the compile dependency between this class and the control panel, I'm adding an interface. So the control panel depends on the interface. It doesn't depend on the main app class itself. So when I create an instance of control panel, I'm going to feed in an iHandler, which if main app implements iHandler, then a main app will be an iHandler. That's how inheritance works. And of course, control panel and floor inherit from the form class. Okay, so let's go ahead and get started here. Let me minimize my, let me just exit out of here. Okay, so what am I using? I'm using Windows Visual Studio 2017 command prompt. I'm just going to do everything using Notepad++ and Visual Studio 2017 command prompt. And that gives me the latest edition of the Roslyn compiler, so I can use advanced features past Visual C# language version 5 if I want to. I'm not using too many of those. And then I have a folder for my projects. So I'll start right here and I'll just say File, Save As. And I'm going to say this is called iControllable. iControllable.cs. Okay, and let me make this bigger because if you're looking at it, I think if I go Command or Control, okay, that's making it smaller. Let me make this code bigger here so you can see the code better on the screen. And I'll just make this like this. Okay, we'll see how this rolls. Now for the interface, I'll just say using system. I always start using system, even if I end up not using it. Using system dot drawing. I'm going to need the point class for my some of the stuff, so I'm going to say using system dot drawing, and then public interface. Now, when would you use an interface? You'd use an interface when you only want to specify the behavior, but you don't want to implement any behavior. Interfaces are used all over the place in C#, Microsoft.NET. All right, so these remote-controlled objects or controllable objects, they're going to have a picture associated with them, X and Y coordinates. Eventually, and I didn't implement this for this particular demo, but they'll be able to draw their path on the screen. And then you can turn them left, you can turn them right, you can set the pin up, set the pin down, you can move them. And so we're going to just define these methods here, right? And properties. So I'll start with properties. The first property is going to be a property of type image. So for an interface, you say public interface, and then you don't have to put public on the property. No, you don't have to put any access specifiers. So the name of the property is picture, and we'll just C# makes it real easy, man. So we're just going to say this is a read-write property. Get and set, just like that. Okay, and then int X will be another property. Okay, and then this will be also read write, get set, and int Y Okay, get, set. Okay. And scroll down a little bit here. The next one will be bool is pinup. Okay, this will just be a simple check here. So we're not, this will just be a read-only property. And we'll just say get. Okay. So we're just, you just declare what you want to do. You don't define what it's going to do for an interface. Now, coming into methods. So turn left. These are methods, so that's just a method declaration like that. And then void turn right. And the next one will be void set pinup. Oops. Set pinup. Now I'm just defining, right? I'm declaring, not defining. I'm just declaring these methods in the interface. Set pin down. All right, and then void move. And void, I'll have two moves. And the second one will be take an argument and spaces. Okay. And that's it for the interface. Okay. Now, if you wanted to make, let's say that our robot, let's say that you wanted to implement the ability to speak, right? Or have them talk. You could just say void speak. Like that. Okay. Now, just because, so we have an interface here. Now, some object or some class has to implement this interface. That's what we're going to do next. We're going to implement a class called controllable object, which may or may not be the best name for that class, but that's what I called it. Okay, you could call it robot, right? But I called it controllable object. So let me go ahead and I'll make this code a little bit less big. Okay, well, let's go File, New. I'm going to save this file as controllable object. So really the big takeaway lessons from this particular demo in this video are how do we, implement an interface? How do we then take a class that says it's implementing an interface and not implement some of those methods and make it an abstract class, and then force the implementation of those methods down in the derived classes. So those are some of the interesting things we're going to talk about today. So using system, let me make my code bigger, a little bit bigger, just a little bit bigger. Oh, that's the wrong way. Okay, using system, and then using system dot drawing. Okay. Okay, let's go back here. Let's see, system.drawing, image, picture. I'm taking a look at my iControllable. Image, picture. Okay, this is coming from the system.drawing namespace. Just want to let you know that's where that image comes from. All right, so that looks good. All right, iControllable. So public, abstract, class, controllable object. Controllable object. Now here we have colon, so I'm going to say this extends or implements iControllable. In C#, a class can only extend one other class, but it can implement as many interfaces as it wants. All right, so the way I read this is if this were a class, it wouldn't have an I in front of it, and you would say, controllable object extends controllable. But since it's an interface, you can read it as implements iControllable. Okay. Now I'm going to also do, I'm going to add protected enumerations here that are only used inside of this class and the ones below it. Okay, so I want to call these this enumeration directions. Directions. And we'll say north, south, east, west. Okay. And protected enums. And pin position. Plural. Up and down. Now enumerations are quite helpful in that they we can, you know, as we go along, right, it's good to compile this stuff just to make sure that you're on the right track. You don't have to be complete with it, right? But let's go in here and do a compile, and I'll get back to the enumeration discussion. CSC star. First off, I'm in controllable objects here, right? Let me make this bigger too. This always gets a little small. So let's go into properties and make the text. I'll do 28. Okay, well that's a little bit better. Here we go. Let's make this not quite so huge. Here we go. I hope that's easier to read on the screen for you guys. Okay. So CSC, let's do a dir first. Okay, there's my controllable object.cs and iControllable. So CSC star.cs, and it says, all right, so it says controllable object CS5. So 5, protected enums. It says a get or set accessor. Directions, north, south. Maybe we just haven't got. Oh, there's no nothing in the class. Let's keep going and see if we can get rid of that. Okay. So private point. I'm going to say this is a field now. Location. Okay. Let me just do a line here like that. So public abstract class, controllable object, iControllable, open brace, and I'll put a little comment down here in class. So these are fields. These are enums up here. That's a field. So this location object is a point type. The point type is located in system.drawing. All right, now I'm going to create a constructor. So public controllable object. And then it will take an image, which I'll call picture here. Okay, and I'll just say picture, capital P, equals picture. You're going to like, where's capital picture at? I haven't got there yet. All right. So now let's do a protected property. Protected directions. So now I'm using this enum. Oh, I know what. You know what? Enum. Enum. That's my problem with my compile. See? All right. Now, okay, so let me finish this and we'll go back and compile it again. So I should have made sure that that was no S on that enum. Okay, direction. So that's the type. So these are the enums right here, right? That's directions. So that's a type. And I'll just say direction, because I want a property called direction. And I'll just say this is a get and a set. This is an auto property. And I'm also going to do an auto property initializer. So I'll just say that the when this class is instantiated, the direction will be set to directions dot east, like that. Okay. So that's a use of a auto property with an initializer. Now, we can stop right there for a second, save your work, and compile. Now, everything should compile. And so we do, it's not like we're not going to get any errors, right? But what we're looking for are errors that don't make sense. But it looks like all these make sense, right? Because what I'm getting now is, let me make this bigger so that it doesn't wrap. It says, that makes it a little bit easier. Okay, so it says error, controllable objects does not implement interface member, right? So all these are saying that, hey, I am not yet an iControllable because I have not provided an implementation for all that stuff that I said was in the iControllable object, okay? Like picture, X, Y, is pin up, turn left, turn right. So all these methods have to have either an implementation or something that says, we're not going to implement. So this is perfectly fine. All right, so that's what I'm looking for the compile. All right, so let's just tuck that out of the way. So yeah, I recommend, even if you're not done coding, compile. The other thing too is you're going to, like, if you're just compiling two classes with no main method, you're going to get an error that says, hey, there's no main. And that could be fine too, right? If you don't have an application class yet. Okay, let's continue to work on this iControllable, this controllable object. All right, so back to the code. Let me make my window bigger. Okay, now the next property. Now what protected means is it's not going to be horizontally accessible to a client, but I'll have direction accessible via, you can access it from a derived class. The combinations of public, protected, and private are really up to you as a designer or a programmer who's designing an application in order to, figure out which classes have access to what properties and methods, and gives you great control. So this will be pin positions. Okay, and I'll call this pin position. Okay, and again, this will be auto property. So get set, and I'll just say pin equals pin position up. Pin positions dot up. So we're going to start facing east, and we're going to start with the pin in the up position. All right. Now, what does pin mean, right? Well, I may or may not use all these properties, right, in this implementation or in this particular version of the demo, but maybe in a later video I will. Okay, I'm just putting these in for future use. Okay, so next one is protected point. Okay, location. That's the name of the property. Now this one's going to use, here I have a field called underscore location, right? So I'm going to use this field. This is not going to be an auto property. I'm going to say get, okay, and return underscore location. And I'll show you why I do this here in a little bit. Set underscore location equals value. Okay, just like that. Now I'm going to get into the X and Y properties. So protected. Well, I want this to be public, these guys. I want you to be able to set the X and Y. Excuse me. Public int capital X. Now get. So here we're going to say return location capital X. That should be dot X, right? And set location underscore location. Let me put a space between here and there just to be consistent. Dot X equals value. So you got to remember the incoming, like if this is an int, this value is that incoming value. But it's an int type. Okay, this is a point. If I'm setting the location, then that value is a point. This value here is an int. Okay. So let's do, let's go image public. So here I'm going to do the picture. And there's no need, this will just be an auto property here. So get set. Auto properties are, introduced in C# version 3. They're big help. Control save. If you didn't have auto properties, if you weren't able to do this, you'd have to do this all the time. You'd have to have a explicit backing field, right? You don't have to do that in C#. Sometimes you need to do it. In this case, it was a necessity, and if I don't forget, I'll explain why. Okay, now is pinup. So this will be a bool. So public bool. So we're just checking, is the pin up? Is pin up? Okay, and this will just be a read-only property. Okay, but this will be a complex one. So what we're going to do here is we're going to say get, okay, and return. And we'll say pin position equals pin positions dot up. So in other words, we're saying, hey, is pin position does it equal pin position up? Okay. Question mark. Is that true? Well, if it's true, then return true. Else, return false. Okay, like that. Semicolon, and that's the end of the property. Okay, moving right along. So now we get into methods. Well, you know what, let's take a break here. Let's compile this thing and see what else it does here. All right, so we get a few less, does not implement. All right, so looks like we got turn left, turn right, set pin up, set pin down, move, and squeak. All right, so some of these we're going to implement here, some we're not. So we're almost done here with this controllable object class. So let's just do a turn left and turn right. So public void turn left. This is a method. Now if we're going to turn left, we have to figure out what direction we're facing, so we're going to do a switch direction. Okay. So it's like, hey, a switch. How you read a switch? You're like, hey, what direction are you facing? Are you facing, this is where case, are you facing direction dot east? Right? And then, well, if you are, then let's do direction. Right? Direction equals, so if you're facing east, then you're to turn left, you're going to face north. Directions dot north. And then break. Well, let's do tabs here. Break. Okay. Now we can do some cutting and pasting here to make our life a little bit easier. So Control C, hit return, go back here, Control V. So now, if I'm facing north, right, then I'm going to be facing west when I turn. Just like that. Come back over here. Whoop, okay. Control V. If I'm facing west, I'm going to face south. Control V. If I'm facing south, then I'm going to face east when I turn left. Okay. Now that we've coded up the turn left method, we can just copy this and just like that, Control C, and copy the whole thing and just rename it turn right and make some changes. So let's just leave this. So if I'm facing east and I turn right, I'm going to face south. If I'm facing north and I turn right, I'm sorry, I'll leave that be. If I'm facing north and I turn right, I'm going to face east. If I'm facing west and I turn right, I'm going to face north. Okay. If I'm facing south and I turn right, I'm going to face west. All right, so that was fast. Finish that method. So, okay, now let's do set pin up. So far, controllable object has implemented everything, but that's not going to be the case here in a few seconds. So, public void, okay, set pin up. This is going to be a lot like, well, you know, set pin up, right? There's only two states, up or down. So we don't even need the check. We're just going to say, you know, pin position equals pin positions dot up. So if it was up, it's going to be just put in the up position again. If it's down, okay. Now the next one's going to be set pin down. Set pin down. Okay. And then pin position equals pin positions dot down. Control save. Now let's compile. So it looks like we're down to 3, right? So we have to do, oh, it doesn't implement Y controllable Y. Let's go back up here and make sure we didn't dork something up. So we have X. Oh yeah, sure enough, man, I skipped one. So let's just go ahead and copy the X. That's the value of compiling. Control C. And just Control V. Now let's change this to Y. And then go location Y and location Y. Compile again. All right, so we're down to 3, right? So move, move, and speak. Now, all 3 of these are going to be deferred. So public abstract void move. Public abstract void move in spaces and public abstract void squeak, right? Make sure I spelled squeak right. Squeak. Ha ha. I think it is squeak. E-E-K. Squeak. Is it squeak? Hang on. I'm a retard, man. I gotta look this up. I get stumbled upon the dumbest words, right? Squeak. Yeah, it's squeak 8. Oh, I got it right the first time. Squeak. All right, let's go back here. Squeak. Okay, so let's just go to iControllable, make sure that it's squeak. Okay. Speak, squeak. Squeak. Okay, so what this means here is that these three methods, even though they are defined or declared in the iControllable interface, I'm not going to implement them here, even though I say I'm implementing iControllable. All right, so I say I'm going to implement iControllable, but because I'm not, I'm going to declare these three methods to be implemented by a derived class. So only a mouse will know how to move like a mouse. You know, that's really the intention, or a robot mouse, right? Or whatever a robot car might move different from a robot motorcycle. Move, that's just a different version of move. And then squeak or speak. Oh, you know, it's not squeak, it's speak. Hang on. Speak. Squeak. I really am losing my mind. Speak. Speak. Okay. Okay. So squeak, I have my mind focused on robot rat. All right. So speak. It's not squeak, it's speak. All right. Yes, I'm going crazy. Okay. So now let's compile. So now we get this error. It says program does not contain a static main method suitable for an entry point. That's fine, right? We don't have a main method, so that means that it believes that everything is cool from the iControllable. We have our move, and speak could declare it abstract. Because we have one or more methods abstract, we have to make the class abstract. So now we go on to, I'll create the rat class, okay, which is back to our diagram. I don't have that diagram open anymore. So let's just go ahead and implement the rat class. So file, new. Okay, and I'm just going to say file, save as, and I'll just say rat.cs, rat.cs. So using system. Now, most of our work is done for us. Okay. Because the only thing that we have to actually implement is the move and the squeak methods, right? Speak methods. Move and the speak. I got squeak on my brain. I'm sorry. Control save. Go back up here using system.drawing. Okay, so public class rat extends controllable object. Controllable object, open brace. Notice we don't have to implement the interface again because controllable object is an iControllable. So the first thing I'm going to do is create a constructor, public rat. Remember, constructor has the same name, image, picture, as the class. And then I'm going to do constructor chaining, so base, and just pass the picture up to the base. Now, if you go back to controllable object, you'll see that the constructor, which is right here, takes a picture as an argument. So rat just takes the picture as an argument and then passes that picture up to the base class. Okay, now, you know, that doesn't mean that we might have other stuff to do in the constructor, but for this demo, there's nothing. So now we're going to implement public override move. Okay, and I'm just going to say that this we'll call move. I'm sorry, capital M. So if you just call move, it moves 1. Now let's go down here. This is a void. So make sure it's public override and then void. And then for the next move method is public override void move int spaces Okay, so here I'm going to say switch direction. Now you're like, where is this direction at? Right? Where am I getting this direction? Go back into controllable object and you'll see that, well, direction. See, there's no direction, right, up in this I controllable, but the controllable object has a protected direction. Okay. The only thing an I controllable needs to know is, hey, it has a picture, it has an X and Y coordinate, and it has a move. Okay, so that's all it takes to be, you know, I controllable. How we're turning, how we're setting the pin up, how we're moving, that's all implementation dependent, right? So the interface could care less about that. Anything that's an I controllable has this interface. Controllable object, right? This is a controllable object. So it has a direction, it has pin positions, and these are protected. Anything with protected means that they're accessible to the derived class, and this rat is a derived class. That's where this property, right, comes from. So switch direction, case directions dot north. So if I'm facing north and I'm moving, right, I'm going to go, so you have to think in terms of X and Y coordinates. So the Y is the vertical plane and the X is the horizontal plane. If you're facing north on a screen, you know, up, that's north to me, right, on the screen is up. Then you're going to just increment Y equals Y minus the number of spaces to move. Okay. And then break. Like that. And then case direction, right, dot south. I did it this way because I kept the y's right. Y equals Y plus spaces. Oops, lowercase. Y plus spaces. Break. And then case directions. No, sorry, directions dot east. Then X, right, equals X plus spaces. Break. And case directions dot west. Then do X equals X minus spaces. Okay, so it doesn't really care. I mean, in this implementation, we're just like, hey, whatever, which way you want to go, we're going to go that way. Or, right, we're just decrementing or incrementing X. Okay. So X is a location, X or Y. And that's the move. Now, one last method to implement, and I'll tell you what I'm going to do here. I'm just going to do public override void speak. And I'm not going to actually do anything with speak. I'm going to implement it, but there's going to be nothing there, right? Just to make sure that that's it. Now, if you wanted to go ahead and implement a speak, you would have to have the ability to play the sound file. I'm not going to cover that in this particular video. I'll do that in part 2 of this video where we flesh out some more of the functionality. Okay, but in this edition of this installment, then I'm not going to implement. I'm not going to actually implement it here. I just have open brace, closing brace, and I'll just say save for later. But as far as the interface is concerned, it's implemented, right? Oh, I can't do that because I have this. I'll just do this. That's all. That whole line's a comment. So I'm going to move this over here like that. Now let's compile. Okay, now we've got the, if you remember the diagram, we got the left inheritance hierarchy implemented. Now let's turn our attention to the forms for the control panel and the floor, and then we'll do the main app. All right, so stand by. Okay, in the first part of this video, I implemented the iControllable interface over here on the left, followed by the controllable object, which is an abstract class, and then the rat class. Now I'm going to turn my attention to the control panel, the floor, the iHandler, and then finally the main app class. Okay, so now we're going to bring this application to life and see how it all ties together. All right, let's get going here. So I can escape out of here. All right, so picking up where I left off, I'm going to create a new class here, or a new file in Notepad++, and just go ahead and save as. And I'll call this one floor. Floor.cs. Now floor is going to extend Windows.form, let's say using system, excuse me, using system.drawing, using system. You don't need a designer. Well, there's nothing really going on this floor, so there's not a lot of components. System.windows.forms. So using a designer wouldn't help you anyway, but you don't necessarily need to use a designer. System.collection. Generic. All right, so what is the floor going to do? The floor is going to manage or manipulate a collection of iControllable objects. And just every time something happens, anytime that floor updates, it's going to repaint all those objects on the floor, okay, on the window. So public class floor extends form, open brace, closing brace. Now I'm going to have a private field here, which is going to be a list of iControllable objects. iControllable is the interface. I'll call this robots. Now I'll have the constructor. So when a floor is created, it's going to take in a list of these iControllable objects. And I'll just call these robots this parameter. Okay, and then what we're going to do, we're just going to set robots equals robots. And then I'm going to call a method called initialize component. Like that. You're like, what in blue blazes? Where's this initialize component method at? Hang on, ain't got there yet. Public void initialize component. I could do all this in the constructor, but I like to bust it out into a separate method. This doesn't have to be public. This can just be private. Private void initialize component. Now I'm going to set the height of the window, or the height of the form, 400. Width equals 400. And the text, which is the title essentially, equals robot floor. Robot floor. Okay, now the last thing for this floor, it's a very short class, the last thing for the floor is that whenever there's an update to its paint, like it's, you know, rendering on the screen, then I want it to do something special, right? So this will be protected. This is how you do it. So you have to override the on paint method, right? And it requires it has one argument, paint event args. Paint event args E. E is the parameter, right? Paint event args is the type. And then I'm just going to have a for each statement. For each I controllable from I'll say robot in underscore robots, like that. So for each I controllable robot in robots, e dot graphics dot draw image, and then we'll say robot dot picture comma robot dot x. So take the image and paint it in the x and y position, and the robot maintains its x and y position. Dot y. Okay. And then once we do that, we'll do base dot repaint on paint. Oh, E, sorry, E. Okay. Base on paint E. All right. You know, I'm not even sure I need this. Let me just comment that out for a second here before we do this. All right. We might come back to that. But let's go ahead and compile. Okay, everything looks good. It just says it doesn't have a main method, which of course we don't. So, on to control panel. Now, control panel is a little bit more involved because it has buttons. Don't let that scare you. Okay. Before we do the control panel, though, I'm going to do another interface called iHandler. All right, iHandler. So, file, new, and then file, save as. Now, the whole purpose of the iHandler interface is to provide a method that will allow the buttons to, button clicks. It'll have one method called button click. It could have as many methods as you want, right? I've just implemented one. iHandler.cs. The real purpose of this class is to break the dependency, because if I'm trying to handle buttons in other objects, then something has to know something about the other, right? So using system. Do I even need this? Yeah, probably. Using system. So this will be a public interface. iHandler. Open brace, closing brace. And then it's just going to have one method. This would be a delegate. Well, it's not really a delegate. It's just a method declaration. Void button click button click handler object sender event args E. So that's it. So in other words, in order to be an iHandler object, you have to have a method called button click handler, which has this signature, which just happens to be an event handler delegate signature. Okay. So now how are we going to use this? We're going to use this in the control panel and then implement it in the main app. So let's go ahead and save that file. Let's compile. Everything looks good. All right, if there was a problem, we would have to fix it. So file, new, file, save as. Now this will be control panel .cs. Save. So using system, using system.component model, and using system.windows.forms, capital F. Okay, so public class control panel, open brace, closing brace. Well, not so fast there, buckwheat. This is going to be a form or a window, so let's extends form. This is very important. If it didn't act like a window, then it's not a window. It didn't extend form. Okay, there's going to be quite a few, a handful, like 5 or 6, right? Private fields. So let's just knock these out. So private. Okay, this will be flow panel, flow layout panel. Yeah, so flow, right? Layout panel, flow layout panel. And I'm going to just call it underscore panel. Private. Button. Underscore move button. And then private button underscore turn left button. You could make this control panel as fancy as you wanted. I'm just doing something very simple because I'm, using a text editor to create it. Button, turn right button. So for example, I'm just using a flow layout panel to flow the buttons from left to right. Next robot. Oh, Bobot. Haha. Oops. Uppercase. So if you're wondering, like, my keyboard is awful clicky, right? That's a button, not a panel. I have a DOS keyboard. Private button. And this will be add robot. And I swear by these DOS keyboards, man. I am not, they do not sponsor these videos. Boy, I sure wish they did. I love DOS keyboard. DOS keyboards are, I use a Mac too. So I do all these, even though, you're looking at a Windows program, right? Okay, prepare to be freaked out, right? So, in case you haven't figured it out, so there's my window. Like, that's my Mac in the back. This is just a VM right here, right? So this is Parallels running on a Macintosh. There's my Macintosh background. And I'm running this whole Windows 10 in a VM. That's the way and of course I have a ton of memory, right? 128 gigs with over, 5 terabytes in a RAID 5 configuration. So I run a lot of VMs. You can see right there is the list of them. Linux and Windows. And you could run Mac OS in another VM too. That seems kind of dumb. Okay, but anyway, back to the topic. So the clicky keyboard is DOS keyboard. And I love it because the switch, this just feels good to type on it. All right, so these are my fields. I have a flow layout, and I have a range of buttons. So underscore move button, underscore turn left button, underscore turn right button, underscore next robot button, and underscore add robot button. And like I say, if you had you can use your imagination, you could embellish this. You could use Visual Studio Designer to create a really spiffy one. Now for the constructor. Okay, control panel. Control panel. Now the control panel is going to take an iHandler. Okay. As an argument. As long as the class that implements iHandler is passed in here, this is how you break a dependency, right? You like, hey, I'm targeting an interface. The object that's coming in, I don't care what it is, as long as it implements iHandler. Then, it's an iHandler as far as I'm concerned. Now I'm just going to turn right around and call another method called initialize component. and just pass in the handler. And then I'm just going to come, that's all my constructor does. All the heavy lifting is down here. So private void initialize component, and then iHandler, handler. Okay. Now this is where all the heavy lifting is going to take place. So here, first thing I'm going to do when you create a graphical user interface is I have a panel. I'm going to create the panel. Then I'm going to create all the buttons. Then I'm going to add all the buttons to the panel. I'm going to add the panel to the window. And then I'm going to set some other properties. So not very much more code, really. This is the only method I have left. And it's, you know, I'm almost done with this class for, you know, this demo. So panel equals new flow layout panel. You can set other properties on the panel. I'm just leaving it like it is. Move button. Move button equals new button. Okay. Move button dot text equals turn. I'm sorry. Move button equals move. That should have been a no-brainer right there, right? And then move button dot click equals handler dot. Okay, so if you go back to the handler interface, the name of the method is button click handler. So all the handlers are going to be the same. Button click handler. This will be plus equals. Don't forget that when you're doing a click, like when you're doing an event. This is an event click, and that's an event handler right here. So it's plus equals. Boy, you will mess yourself up if you just put equal. Well, you get a compiler error if you just try to do equals. Okay. So you know what I just told you, is that true? Let me just undo this. Hit save and come over here and do a compile. And yeah, it says the event can only be on the left-hand side of a plus equals or a minus equals. So this has to be a plus equals, like that. So let's go down here now. This is the turn left button. Turn left button. I'll speed this stuff up because there's a lot of repetitive stuff until I get down towards the bottom. Okay, so don't worry about following along for every one of these things. So turn left button equals, really the pattern is you create a new button. You have to create the button. And then here, and then set any properties. Here I'm only setting 2 properties. Well, 1 property and 1 event. So turn left dot text, which is the title on the button, right? Equals, and in this case it's turn left. Turn left, and then turn left button dot click plus equals handler dot button click handler, like that. Okay, now I'll speed everything up. Okay, I have all the buttons created and the properties set. Now I'm going to add the buttons to the control panel. So you go panel dot controls. Controls is a collection. Just call the add method. Okay, and they're going to flow from left to right in the order that I add them. So I'm going to say, let's do add. We'll do add robot. Well, yeah, this will be a little bit different from what you saw at the beginning of the video, but this probably makes more sense. I'm going to do add robot button. All right, so we're going to add a robot first, and then we'll say turn right. So panel dot controls. This is, you know, once you do this, you can always change it. Turn left button. I guess that makes sense. Panel dot controls dot add. Turn right button. And then panel dot controls dot add. Turn left, turn right. Next button. Move button, like that, and then panel controls dot add. Next, robot button. So turn left button, move, turn right button, move button, and next robot button. Now, once we have all our buttons or controls added to the panel, I'm going to add the panel to this, to the window. You don't have to put this, but controls dot add underscore panel. So you put everything in the panel, then you add the panel to the main window, and then just set the, I'm going to set the text, next thing. So I'm setting the title of this window here, equals robot control panel. Robot control panel. Notice I don't have a button for squeak. I'm not implementing the squeak method. The speak. I'm not implementing the speak functionality. I'll do that in another video because it involves sound, right? I have to have sound file. Okie dokie. So this .text, robot control panel, and that's it. So let's compile. Let's come down here and choke up a little bit. Delete. Delete. I'm just closing up the spaces in the code. All right, so let's compile and see if we dorked anything up. All right, so it says it does not contain a definition for controls, and certainly it does not. C-O-N-T-R-O. Got to spell controls correctly. Let's compile that again. And then we get the button does not contain a definition for click, lowercase click, right? So let's go up here. Oh, there it is. Click. You know, you guys watching this video might see some of these mistakes as I type, right? But when you're like sitting right in front of the dang screen, sometimes you just don't see those mistakes as you make them. That's why you should compile often, right? You don't want to type all this code in and then compile it in one fell swoop, because you would just commit suicide, right? You saw those errors scroll off the screen. It makes it easier to like code a little bit, compile it, right? Make sure that you got everything right, that it, you know, there's no obvious mistakes, right? That doesn't mean your code is good code, right? Your code might frickin' blow chunks, but you know, at least you caught some of the big gross errors before proceeding. Okay, so I have everything coded except for the last bit, which is the main application. Okay, that's the most important part. So let's work on that one. Okay, and this is the last piece, right, for this video. All right, so File, New. File, Save As. Now this will be the main app. We can get this thing running. Once we get the main app coded, we can like start playing around with it and then add stuff as we go. So this part will become more interesting than the other previous parts, right? So main app, I call it main app because, you know, I don't know what else to call it. All right, so the main app is the class that has the main method in it. So let's just get the preliminaries out of the way here. Using system.component model. Okay. Using system drawing, using system.collections generic, and then lastly using system.windows.forms. Okay, so public class main app, okay, implements iHandler. So this is going to be our handler class. This class will be a little bit long, so I'll put that in class just so I know where I'm at. And I'll come down here and I'll put a main method, pav stack void main. Now, what am I going to do in main? I don't know yet exactly, but I do know that I'm going to have an instance of the floor, so I need to say private floor. I'll need an instance of the control panel. Okay, so I have now I'm going to need somehow to manage all the robots. I'm going to need another collection. Private lists, right? iControllable. iControllable. Notice I'm not referencing controllable object or controllable object anywhere, right? It's all just iControllable. When I create like a rat, or when I create an actual concrete implementation of one of these controllable objects like rat in this case, right? I have this rat class. You could have any number of these, you know, this is a concrete implementation of a controllable object, right? Because it implements these methods, right? That were not implemented in the controllable object. So that's why this is concrete class, right? Provides an implementation. Even this is an implementation, the speak method. Even though the braces are blank, there's braces there, right? So that means there's a body, even though it does nothing, right? I just needed that to make it, you know, implement. So I'll just call this robots. I'm back to my main app class. And I will need a list. So I need like a pointer to private int to the current rat. Not rat, current robot. Right, rat's just one robot. There could be many different robots. Now let's do the constructor public main app. Okay. So when main app fires up, I'm going to create an instance of the robot. So robots equals new. Okay. List iControllable. Like that. So I have a list of robots. Nothing in them, but there's a list now. Floor equals new floor. Okay. Now, floor, if you go back to the floor class, the floor needs a list of robots, right? That's a reference. So I'm passing it a reference, right? That's what anything you do like this is being passed a reference. So go back to main app. That's why I have to create, right? Make sure that's created first. And then I pass in robots like that. Okay. Then I need, then I'm going to set. So here I'm going to set the floor. When I click on the floor, floor.click plus equals floor click handler. Floor click handler. And I'll have to define floor click handler down there later on in the code. Okay. Then I'm going to create, well, let me see. I'll initialize current robot equals 0. Current robot will already be 0, but I'm just specifically saying that's what I want it to be. And then control panel equals new control panel. Now I'm passing in this because this is the handler, this class that I'm in. This is the main app, right? The main app class implements iHandler. So when I create the control panel, its constructor, let's go to the control panel. Its constructor is expecting an iHandler object to be passed to it. And that's what I'm doing. This is an iHandler. Main app is an iHandler because it implements iHandler, or it will here in a second. Therefore, control panel this will work. Now, I'm going to say underscore control panel dot closing. This is an event plus equals control panel closing handler. Control panel closing handler. And then I'm going to show the panel. Control panel dot visible true. Okie dokie. So let's go down here and implement some of these methods, right? So really, for this iHandler, okay, for the iHandler, I have to have one method called button click handler. So let's go back here and go public. Let's see if I can do private. Nope, it has to be public because I'm, you know, it's being assigned to. Has to be accessible to those other objects in the control panel or the events. So public void button click handler object sender event args e. Now I'll come back to the implementation of this particular event or this particular method. The next one I'm going to implement is floor click handler private. Now this can be private because it's just used in this class. Void floor click handler. These are all event handler delegate signatures. Sender event args e. Okay, then I'll come back to this method. And I'm going to implement. I'm just trying to get this thing to compile. So private void. This will be control panel closing handler. And the reason I'm doing this is I want to kind of give you the rationale for why some of these I've implemented some of these methods. Object sender event args e. Okay. Now, let's just do this. So now we come down here in the main app. So let's get this thing running. Let's do application dot run. Well, we have to do this. Let's do main app ma equals new main app, and then application dot run ma dot underscore floor. We have access because we're in this static, this main method is inside of this class, so we have access to these private variables. It's one of the few times you do have access like this. And because this floor is not declared static, you have to have an implementation, which makes sense. All right. So we have an actual object or reference to an object, and then we can access the underscore floor. So we're running floor, right? The main app is not a form. The main app is just some code. The floor is a main app. So I'm going to run the floor. Okay. Now let's save this and let's run it. See what happens. Compile it. Okay. Oh, event arts. Right here, I mess up. See that right there? You guys probably saw that. I didn't see that. All right, let's compile it. Okay, so we have a warning. It says main app current robot right up here is assigned, but it's never used, and that's fine. So let's go ahead and run main app. So this will be the first time that we're running this thing, and we can see what we have in front of us. Okay, so turn left, turn right. I'm missing a few things here, but we'll go back and fix these. Okay. All right, so there's my control panel. Here's my floor. If I click on these buttons, nothing happens, right? If I close this window and click on the floor, the robot floor, nothing happens. So let's go back and let's fix some of these issues with this code, right? And finish this class. And once I get done coding this thing, we'll be done. Okay. First off, we go to the control panel, right? And when this control panel powers up, right, those buttons all look, well, let's run that thing again. I'll show you what I'm talking about. So here we have, first off, when the application runs, this is the application, this is the window that's running. So this is handling the events. This control panel gets set to visible, right? But it gets opened over here. So I'm going to change it so we open it over this way. Okay. So I kind of shift it to this side. And then yeah, and then see how these buttons are kind of scrunched up, right? I need to set the dock on the control panel. So let me just do all that stuff. All right, so going back to the control panel. Gotta find my code. Okay, let's go down here. So underneath a panel dot dock equals dock style dot fill. Okay, panel underscore dock equals dock style dot fill. Okay, control save. Now let's compile this thing again and run it. So now when we can resize this and these buttons reflow. That's kind of what I was looking for right there. Okay. Now the other problem is when this panel powers up, it's located behind the floor. I want to set it over to the side so that we don't have to drag it every time. So let's go back to the main app. Okay. All right. Okay, so here in the main app, we need to go to the control panel and set the start position. So this dot start position equals form POS dot center screen. All right, let's compile this, make sure we didn't dork anything up. Okay, so let's run it. So now we see where robot floor comes in over here, like that, and the control panel is here. All right, so let's go ahead and do a Control C, stop everything, and run it again, see what happens. Okay, that's fine. We could also set the position on this robot floor as well. Okay, but we'll leave that for a later video. Okay, now, once we have all that, Control Save, main app. All right, let's start fleshing out the rest of the main app here and actually get this thing to do something. All right, so button click handler. Okay, now button click handler. So if you go back to control panel, you'll see that all these buttons have the same control handler, or the click handler, button click handler. So how are we going to manage that? Well, we're going to do a first off, we're going to have to create a button. Okay, button, right? And I'll say B equals button sender. So we're coming in with an object, but I want a button, okay? Because an object doesn't have a text property. So then I want to say switch on b.text, okay? So, case. Okay, so case add robot, right? So in other words, if the button comes in with add robot, I want to call the add robot method and then break. Oops, let's just text. Let's just tab over here. Break. All right, you're like, well, add robot, where the hell did that method come from? So let's close up there. Now I'm just going to say private void add robot. Now for testing, right, as you're coding along here, you can just do like a little console message. So console right line add robot, okay, button click, okay, like that. And you could do it another way too. Let's say that you don't trust, let's say you don't want to do that, right? You could do, you know, you could say add robot string just to be sure, right? String text, and then up here you could pass in b dot text, okay, and then you could say text plus space plus or button clicked. Okay, so plus space button click. There we go. That's better. So whatever that text coming in plus button clicked semicolon. Now let's try this. Okay. So let's go ahead and compile. Okay, let's run it. So now we see over here, well, there's nothing going to be shown on the floor, right? But when I say add robot, I see add robot button clicked. Okay, just like that. Now I'm going to go ahead and I'm going to keep that trace in there. And what I'm going to do is just flesh out these. So we'll say case next robot. Now these texts, right, so you got to make sure that you're putting in the right one. So next robot, right? Next robot, b.text, break. So let's go down here and add next robot. Next robot, text, and then just copy this. We're going to come back and add some functionality, obviously, to these methods shortly. I'm just fleshing it out, and this is called stubbing, where you're you're adding a method, but you're not sure exactly how to do it. So then you implement the method, you put a message in there to let you know that that method's being called, and then you'll come back around to actually add something to it. So let's go ahead and compile this one, and then I'll just implement the rest of them, and then we'll get going. So main app. Okay, now if I do next robot, I get the next robot, add robot. Okay, so let's do turn left, turn right, and move. Okay, let's close this down. We're just going to implement all these. So case turn left, right, turn left, text, break. Okay, now I can just copy this. Turn right. Be careful when you copy and paste. Sure can screw yourself. Turn right. Not like I've never done it. Turn right. Break. And then move. Well, just come back up here and hit paste. Case move. This will be move. Okay, and then break. Now, okay, so we need to add a few methods here. So I'm just going to go here and copy. So we turn left, turn right, and move. Turn left. Turn left. Turn right. And move. Okay. Now let's go ahead and implement these turn left and turn rights. These are actually pretty easy to do. All right. So the first thing we need to do is You need a picture. Let's do the add robot, right? So we'll add the robot. When I create the robot, I'm going to need a you'll need an image for this picture, for the picture of the robot. Okay, so I'm implementing a rat, and I have a little GIF I'm going to use. Let me go grab that thing. Rat.gif, copy. Okay, let me go back up here, put it in my main folder, paste. Okay, let's just take a look at rat.gif here. It's hard to see, but it's right here, a little picture of a rat, right, or a mouse. Okay, so now when I add the rat or the robot, right, if you had more than one type of robot or concrete class, right, I only have one, rat, you would have to have some way in the control panel to tell it which one you wanted to add. That could be another button, it could be like a text box, a checkbox, but I'm only doing like a very simple, like click a button, add a robot, and it's going to add the same one over and over. Okay, so I'm going back to my main app, into my add robot, and then come here, and the very first thing I want to do when I click this add robot is I'm going to create a picture, image, picture equals, now there's a bitmap class, new bitmap, okay, and you just give it the name of the image that you want, so rat.gif. Now here it just assumes that it's in the working directory. Okay, but if it were like in an image, you'd have to give it the path if it was in a different folder. So I'm creating an image, okay, and then I'm going to say robots dot add new rat picture, like that, okay. And then I'm going to, all right, so I add the rat, okay, and then I want to refresh the floor, so floor dot refresh, like that, okay. Now what that will do, it will force, and then I can leave this trace message in there, console write line. But I'm adding the rat to the collection, okay, of robots. And then when I refresh the floor's paint method, let's go to the floor class, the floor's paint or on paint event. Okay, so let's see if this works. Remember I commented this piece out thinking I didn't really need that. Okay, so let's go back to main app, hit save. Now let's just test this and see what happens. So we're going to compile it and run main app. So let's add a robot. Okay, so that seemed to work. Now what happens? We need to move. Let's do the move method next. So we'll do move. Right now all move does is just click, right? So all these buttons, right, should work. So turn left button, turn right button, add robot. Oh, there's two robots on there now. Next robot's not doing nothing. Okay, except for the, so let's close that one, right? Now for the most part, excuse me, let's do move. So come down here, all right. So all we need to know is, this is a pretty simple method to implement, okay. So we're just going to say robots, right? And it's a collection, so we're going to say current robot, whichever one is selected. Dot and since, right? Since the collection holds iControllable, we can just call the method on the whichever robot that we're accessing at that position. Okay. So we're just going to say move, like that. And then it's up to the robot to move, right? Now there's also a move spaces method, right, which we could call, but we would have to figure out some way to pass in spaces from the front end to this main app, right? And that's probably show you how to do that in the other video, next video, along with the sound. Okay. So current robot. Now, you know what? Let's go to the next, because the next method is pretty darn important. Next is, what we're going to do is we're going to say if current robot, I'll say if plus plus. So we're going to increment the robot. Current plus plus robot greater than or equal to robots. So this is a collection. Robots.count. That's a property. So in other words, if there's, you know, 2 robots in there, then we increment the current robot from 0 to 1, right? And that's fine. But if we go from 1 to 2, right? If, let's say there's 1 robot in there, we go from 1 to 2, then we want to, if it's greater than the count, we want to say current robot. We just want to reset it, not control panel. We want to reset this to 0. Current robot equal to 0, just like that. Okay. If you want, you know, as you implement these methods, you can take out these tracers, right? I'll leave them in there for now. Control save. Okay. Now, let's go ahead and run this and see what we got. So, control panel, CSC. All right, now that warning goes away, right? So, main app. So, add robot, move. We haven't implemented, oh, we did implement a move. Okay, turn right, add robot, let's see. Next robot. Our robot's not moving. Robot's not moving. All right, we'll have to figure that out. Oh, okay, oh, I know why. Here's why. So, when we move, right? So, we need to refresh. So, let's go back here and go, just like when we added the rat, we added the robot, right, to the thing. We need to just copy this piece of code right here. Floor.refresh, Control C. And in our move method, we need to come down and put that in there. Well, let's just do it right here. So floor.refresh. Now let's compile again. And let's run it. Add robot, move. Okay, now you see the robot's moving, right? That's because we're redrawing the image at our new X and Y location. Okay, go back and look at the rat.move code. Now if we turn right, nothing's going to happen because we haven't implemented turn right. But all we have to do is just hook that method up, right? So we already have, you already saw how move, okay, works. Same thing for turn right or turn left. Let's go turn left, right? So we'll say, we can just copy this code. Robots, Control C, turn left, Control V, turn left. Now while we're at it, we might as well just do turn right. Okay. Turn right. Okay, a couple notes here. If the turn left, let's say that you had different images for the way your robots are facing, then you would want to do a floor.refresh. In fact, we can just go ahead and put in floor.refresh. even though you won't see any change, if you did have different images for turn right, turn left, which I have not done in this particular version, this would come in handy, because if your image changed but you didn't refresh the floor, you wouldn't see the image change, right? And I think maybe in the next video I'll show you how to do that, where you swap out. I'll swap out every time we turn. We'll have a different aspect on the image, right? Let's go ahead and compile this and run it. All right. So add robot, move. So turn right, move. You see how I turn right, right? It called the turn right. It incremented, it changed the direction of the mouse. Turn left, that move. Next robot. Well, let's add another robot. So there's another robot. Let's go next robot and move that guy. You know, whenever we add a robot, we could just increment we could set the robot to that guy, right? I haven't done that yet. So now if I hit next robot, we'll move that guy, right? Like that. We could probably do something to get rid of the flicker on this image, but I'm not going to do it in this video. All right, so let's go ahead and okay, now we've got most of this stuff done. Let's just do another couple things to make this app a little bit nicer, right? So right now, if I close this control panel, then there's no way to recover it. So let's go ahead and fix that. And we already got some of the code in there to do exactly that. Sorry. So let's go back up here to scroll down. I've got floor click handler and control panel closing handler. The problem is, let's go back, let's run this thing one more time. In order to solve that problem, which problem are you talking about? If I close this window, let's say I had a button here and I tried to show that window again, right, that panel, I would get an error because Windows releases all the resources for a window when you close it. So when I click on this X up here, I close that window, all the resources for that window, and you'd have to create a brand new window. But you can hide and you can show a window. Not close, you can hide and show, or set the visibility to true or false. But you have to intercept the closing. So when I click that close button right there, that generates a closing event. If I intercept the closing event, okay, I intercept that closing event, then I need to just say, hey, look, don't close, right? But hide yourself. That's what we're going to do. That's the tactic, okay? So that's what this floor click handler. So when I go up here in the constructor, I say control panel closing, that's the closing event, plus equal control panel closing handler. It's going to call this method here when it starts to close. And here I'm going to say e.cancel equals true. So cancel the close and just hide yourself, or hide the control panel. So the way that I do that is when I click on that window, that's the sender of this event. So I'm going to say form sender dot hide, okay, or I should say visible equals false. There we go. So don't close, because I'm saying cancel the close, and set visible to false. And we'll handle the closing of the window and release all the resources in the main method later on. Now for the floor click handler, what I want to do here is I simply want to do control panel dot visible equals true. So if it's true already, that's fine. That's no problem. So save it. Let's compile it. And it says event args does not contain a definition for cancel. Oh, this is not an event args. This is a cancel. Cancel event args. My bad. Okay. Okay, so let's run it. All right, so here we have the robot floor. We have the control panel. Now let's add a robot. Turn right, move. Let's close the control panel. Now let's click on this one, show the control panel. Let's close the control panel, click on the floor. Okay, so we got that piece working there. All right, that works all day long. That works nice. Now when we shut down, we're going to have to make sure that we wrap up our resources. How are we going to do that? Let's go back to the main method. Okay, we're almost done here. We're just doing a quick little tidy up. I'm going to put in a couple try catches. First off, I'm going to say try. Okay, catch, exception, and I'm not going to print out the exceptions. I'm just going to swallow them. But I might do some printout methods, messages. So I'm going to try catch. I'm going to do 2 of these. Okay, Control V. So the first try, I'm going to say try to close. So floor dot close. Okay, and then I'll put out like a console right line print floor close. Or I'll say console right line. I'll say exception. Closing floor. And then I'll just repeat this for, I'll just take this, well, that's all right, I'll just do control panel. I really want to make sure the control panel's closed. Because it's the one that's being shown and hidden, right? So if I don't close, I just want to make sure it's properly put away. So console.WriteLine, let's just copy these. Control C. Control panel closed. And then Control C. And this will just give us some indication of whether or not these calls were successful. Control panel. Okay. So I think with this, let's go ahead and compile it. Okay. Oh, I just can't say floor. I have to say main app ma dot. I have to use this reference to these guys. And ma dot control panel. All right. Let's compile that again. All right, main app. Okay, so now we have the robot floor. We can add a robot. We can add as many as we want. Here I added 2 more. I'll move this guy out. That's the first one that I added. Let me get him out there. I'm just moving one pixel at a time, right? Now let's go next robot, and I'll turn him right, and I'll move him. Like that. Okay. And then next robot, that's that guy. Right there. Okay. So that seems to work fine, right? So we're just moving stuff around the screen, but we have this inheritance hierarchy using interfaces and an abstract class. You can add as many concrete remote controlled objects, or robots as I'm calling them, as you want. All right, so rat is just one. So what you would do is you'd extend controllable object, look at the rat class, figure out how I implemented that one, and then create another picture. I used Photoshop to create an image GIF. Right, I pulled this image off the internet. I shrunk it down in size. I saved it as a GIF image, 50 by 50 pixels wide. Okay, so you can make it as big as you want. You can make your floor as big as you want. You could change your control panel. Okay, now you could have a clear button, which would clear everything. But now the way it's implemented, if you close the control panel, you can click on the floor and it'll open it back up again. So there's some neat tricks in this code. And anyway, that's it. If you have any questions, comments, feel free to reach out. In the next video, I'll show you how to implement the speak method, use a sound file to actually get these guys to talk. That will require adding another button to the control panel, and then adding another, back in the main app, adding another little piece of code in the button click handler to call a speak method, and then figuring out which sound file. Whenever you create a remote controlled object, you'll have to associate a sound file. So I'll show you how to play a sound, and to make these things speak. So that would be in the next video, part 2 of this little series. All right, this was part 1, rather long video, but a lot of great information. You guys have a great day.